Hey guys, welcome. In this video, we are expected to solve for the value of x in 6 power x plus 6 power x plus 6 power x divided by 2 power x plus 2 power x, and that's equals to 36. Can you try and know the value of x? But first thing you understand is that we have 6 power x into 3 places, so we can factor it out. So if you factorize 6 power x, you are left with 1. Factor 6 power x, you'll be left with 1. Factor 6 power x, you'll be left with 1. Then all divided by, same thing here, factor out 2 power x, you are left with what? 1 plus 1. Okay? And all of them is equals to what? 36. Okay? So let's count. We have it as 1, 2, 3. We have 3, right? So we can say we have 3 lots of 6 power x, okay? Divided by, for this we have 2 lots of 2 power x, and that's equals to what? 36. Okay, so what do you understand here? First of all, we'll try to get rid of this 2 over 3 that is here, and to do that we have to multiply both sides by the inverse, and the inverse of 3 over 2 is what? 2 over 3, so that everything can cancel. And since we are multiplying it to the left hand side, we should also multiply it to the right hand side to maintain equivalency. So if you multiply it, what do you observe? 2 will cancel out 2, 3 will cancel out 3, everything is gone. Then here, 3 divide is 1, 3 divide 36 is 12. Okay? At the end, we will be having 6 to the power of x divided by 2 to the power of x, and that's equals to 12 times 2 is what? 24. It's that we have that a to the power of m divided by b to the power of n is, from the law of indices, we have that a to the power of n divided by b to the power of n. We can still write it as a over b all raised to the power of what? N. Okay? Factoring out the common powers. Okay? So if you have that, we can still really apply it here. So we can now write 6 over 2 all raised to power x, and that's equals to 24. Okay? So you observe one thing, 6 divided by 2 is 3. So we can say 3 to the power of x is equal to, what's left here? 24. Okay? If you have this now, what do you observe? You observe that 3 and 24 cannot be expressed in common base. So all you need to do for me is to take the logs of both sides. So if you take log of 3 power x, and that will be equal to log of 24. The reason why we are taking this log is that in logarithm allows us to multiply the power of the exponent in the number to the log. So here, since this is x, we can now have it as x log 3. Multiply the power to the log, and that's equals to log 24. Okay? So if you have that now, what do you observe? 24 can be, we can now divide through, since we are looking for x, by log what? 3, and divide both sides by log 3. If you divide by log 3 and log 3 cancels out, we are left that our x is equal to log 24 can also be expressed in terms of 3, right? Because 8 times 3 is given 24. So we can write it as log the product of 3 and 8. Okay, they are still 24 divided by log 3. Okay, so from the laws of exponent logarithm, whenever you are multiplying in the same base in a logarithm, you are free to express them and sum them in individual logs. So what do you have? X is equals to log 3 plus log 8 all divided by log 3. See that x is equals to, we'll split the fraction, log of 3 over log 3 plus log of 8. So 8 also can be seen as 2 to the power of 3, which is 2 times 2 is 4, times 2 is 8. So we'll have it as 2 power 3 divided by log 3. Okay? So here, log 3 by itself is 1. So x is equals to 1 plus. So here, from the same rule, whenever we have a power, we are free to multiply it to the log. So we have it as 1 plus 3 log 2 divided by log 3. Okay? At this end, we are going to use change of base to simplify the last term, showing that x is equals to 1 plus 3 log, since they are of common base in log, so log 3 of 2. And this is the simple answer to the value of x. Do well to like, subscribe, and share for more exciting tips like this.